Please consider purchasing the new Partially Examined Life book, a breezy read and excellent memento, the ideal gift. Learn more at partiallyexaminedlife.com/book.
You're listening to The Partially Examined Life, a podcast by some guys who were at one point set on doing philosophy for a living, but then thought better of it. Our question for episode 340 is something like, how can essentialism help us better understand the world? And we read chapters 5 through 8 of Brian Ellis's 2000 book, The Philosophy of Nature, A Guide to the New Essentialism. This is Wes Alwan, observing all the laws of nature in Cambridge, Massachusetts.
This is Seth Paskin, drinking with Dretsky and Duham in Austin, Texas.
This is Dylan Casey, conserving my form momentum essentially in Madison, Wisconsin.
And this is Christopher Heath, not being born great, not achieving greatness, nor having greatness thrust upon them in North Hollywood, California.
But potentially great. Dispositionally great. It's one of your causal capacities.
True. It's one of my.
So Dylan, welcome. You weren't able to make the first episode where we covered chapters 1 through 4. So I thought I'd start off by asking you about your thoughts on that. You had a chance to listen to our conversation about that. So maybe you could catch us up on some of your thoughts, and we'll treat that as a segue into chapters 5 through 8.
Yeah, so I really enjoyed the book, and I thought you guys did a really nice job covering it. My biggest takeaway from especially those sections is this whole idea that things have essential dispositions. I guess that'd be the way to say it. That the way in which the distinction in the new essentialism, or this refinement of it, is understanding that the fundamental entities in the world, the way they are and the way we ought to understand them. And in fact, I think Ellis claims the better way to understand how modern science actually works is looking for what are the ways in which those fundamental entities work. So when we talk about entities in science, and indeed, I think he would say when we talk about entities in the world in general, we would be talking about the way they behave, the way they act, their dispositions. And he, of course, is focusing most on things that fall into effectively natural kinds, things that have essential dispositions. That's what we're trying to discover. They're not accidental, they're objective, meaning that they are independent of how we think and talk about them. And that is both a criteria for whether or not we found an essential characteristic. You know, we have to be able to take the stance that it has to be independent of the way in which we think about it. And then it also leads to this really interesting requalification of different kinds of things. You guys had a nice discussion of color, for instance. It makes the discussion of color a lot more sensible in my mind. And I think that the distinction he makes, the passivism characteristic of, roughly speaking, a Humean take on the way in which the world works, again, is an apt characterization that leads to a whole bunch of challenges, which they're the challenges that litter the history of philosophy of science for hundreds of years. And his claim is that this addresses them better. This both aligns with our intuitions, the way in which scientists think about things actually, not just philosophers of science, but actual scientists. And look, I come away thinking that there's something really, really right about what he's talking about. The idea that you would say, well, look, my account of an electron is not that it's used ball bearing, that happens to have a charge that's plus and that happens to have a weight that's 0.511 and stuff like that, MeV. That some of those properties are essential characteristics that govern the way they act. That's the way they are, and that all of the resulting actions that come out of it are the eminent phenomena. So this, the other big idea to me that I liked was the laws that we characterize about the way the world works are not the thing that gets laid on top of the entities, but rather the entities' very characteristics come together into law-like behavior. And that is what you see. So if we think about, he talks a little bit about crystals, but when you say, okay, well, this crystal forms a octagon, there's this fundamental octagonal characteristic of the way in which the atoms form in that crystal. And that is completely comes out of the shape of the atoms that are in there because of the disposition of the way they arrange. It's not because some other law, something else acts outside on those atoms and then says, oh, well, you're going to happen to form an octagon. And that thought in his account goes all the way down so that electrons are entities that have a negative charge, that are characterized by an electric field, and then all the other interactions that they happen to. It's not that electric fields happen to be there or that there's an electric field law that gets added on. They arise as eminent characteristics of the individuals. That to me seems also really, really powerful and also answers a lot of questions about philosophically about the way in which laws work in the world.
Yeah, so we'll get more into the laws of nature in this episode. And Dylan, I think one of the upshots of what you were saying is that the laws of nature are better thought of as emergent on the essential, intrinsic, dispositional nature of things. It's not like there's this external set of rules or algorithms, and then you take these little like ball bearings or these pre-established things which don't necessarily have any properties, and you say, okay, they behave according to these rules, and then it makes them look like they have these dispositional properties. So when an electron is disposed to do X in circumstance Y, you can either think of that as, well, here's an electron, it has its identity, it is what it is, and then it has the rules that it follows. But in a way, an electron just is the rules that it follows. It's the way Ellis puts it. Its identity is really reducible to its dispositions. And I think our instinct, and I think what he thinks the instincts of philosophers have been, is to say, well, no, these dispositional properties should be reducible to categorical properties because that's what we're used to at the macro level, at our phenomenal level. We want to say, why does it do X? Well, let me look at the visualizable structure of the thing. How are its parts arranged? What are its static properties, in other words? If I want to talk about an event, I want to talk first about the things and then how they move around and all of that stuff. But I think the most interesting part of this book is to help us imagine that these dispositional properties might be the basic things, not the categorical properties, but the dispositional properties are basic. And then what we think of as categorical properties would be reducible to dispositions.
You guys mentioned this in the first episode that this distinction between dispositional and categorical is a lot like becoming versus being. I don't know enough about the intellectual history here. We've done the podcast long enough to know that being versus becoming is an old problem. But the notion that what something is not tied up with what it can become fundamentally, that entities don't come with dispositions. Every time I think about it, and then seeing it articulated here, and all the problems that arise from not including what the dispositions of something are in what it is, just seems to be sort of a weird kind of, oh, we grab the elephant from this side, and so we're stuck thinking about only the being and not the fact that it has properties, dispositions inherent to it in its essential character that also govern how it becomes. It just seems like a big mistake.
It does. I do think that Wes is right to point out that it comes from our intuition in terms of seeing the macroscopic world. I mean, it really does seem like there are entities in the world that have this sort of static structure that don't, like a rock doesn't have an intrinsic activity. But upon closer inspection,
I think that those intuitions, this would require a lot more, sort of intellectual history, right? But I mean, look, Aristotle thought in broadly speaking these ways 2,500 years ago. And I am certain that even talking about like things like animism and other kinds of what we would call primitive ways of thinking would assign powers to the way in which things work. And if I look at a rock, right, the very first thing you're going to have to do in talking about a rock is that it has the power to resist you going inside it, right? Even back with Newton and early modern science, right? Impenetrability comes up right away, right? The thing that stuff can't occupy the same place at the same time. Even if you want to say, oh, well, that's not an intrinsic property, that's not essential to it, right? You have to throw it in there.
Yeah. I mean, there was a history of vitalism as well, having like an intrinsic power to move it, so things like that. It just maybe throughout the intellectual history, it didn't prove to be as powerful in resolving certain problems in philosophy of science. And so people started to gravitate towards, especially with Newton's. He talks a little bit about Newton and Leibniz going back and forth later in the book, but Newton's theories being so powerful and his sort of assumption that this sort of Humean assumption, I think, is some of the reason too that ended up pushing us in this area of not including potentialities as real things, intrinsic activity as real things like that. Some of it may just be the historical record of Newton's theories being so explanatory.
As somebody who's not as educated in the history of science or science itself, what he's pointing out, this notion of ascribing laws, governing characteristics that are imposed upon things from the outside, is equivalent to what we call in philosophy reification, right? You give something a name and it becomes a thing. So if you think about it, if everything that goes up must come down, right? Every time you throw a rock in the air, it falls down. And you're like, oh, there's something that makes everything hit the earth, right? Come down from the sky. Let's call it gravity. Gravity governs everything on earth, is subject to the law of gravity. That line of reasoning seems very natural and intuitive, right? Because we can't grasp the concept, at least as human beings initially, that the earth itself might be in that equation, right? And having the intrinsic property that it mass attracts mass or whatever. So it just seems that what he's pointing out, I think very convincingly, is that scientific, let's call it for the purpose of this conversation, something like trying to establish scientific or physical ontologies, biological, chemical ontology, something like that, is subject to the same types of intellectual errors that we get in other places, where just because we have a name for something doesn't mean it's an actual thing. It's like substance. It's essentially the same mistake, and he's trying to come at it from a different way.
This probably isn't the book to delve into it because he has a bit of the intellectual history on it. But I suspect that the way of viewing the world and the way of interacting with it, we're understanding things as having inherent dispositions, is something that's been fundamentally part of human culture for a very long time. And the particular version we have in the account in modern science is probably the more unusual one. And I'm thinking like everything from like just cooking or building something, like the ways in which you would pick out how things fit together. And that process of figuring out is, to me, in a very natural way, from kids, and older cultures to modern cultures, and just the way we interact with things now is we look at objects in the world and things in the world, and we associate them with one another about how they work.
Part of the problem, I think, in drawing these analogies from the macro level is we're stuck with what's visible in a way, and a lot is invisible. He'll get into this in several ways in these chapters, one of them having to do with using imaginability as a criteria for necessity, which he's going to reject. And I think that's a very interesting and strong part of the argument. But also just that the boundaries of things are actually unclear to us. So that a macro object is actually distorting space-time around it, and that's the way we ought to think of gravity. And even further, that distortion is actually part of what the object is. Again, it's part of its identity. It's part of what it is to be that object. It's not just an add-on, let's say. And Dylan, you were mentioning Aristotle, and I always think about, as I read about dispositional properties, I'm always thinking, potentiality. Aristotle was kind of right. We can't really do without this concept of potentiality in a very deep way.
Yes. And we mentioned Newton a bit ago, and Ellis brings us up, and maybe this gets us starting into laws. But, he refers to Leibniz versus Newton, and Leibniz having vis viva. Leibniz is mv squared, energy, and Newton is mv, is momentum. And if you go through education in physics, you're going to end up approaching problems at the beginning in terms of forces, entities, you have forces, and you do calculations based upon force laws. Pretty quickly, you also start interacting with things in terms of energy. And there you're talking about the energy of its motion as well as its potential energy. And there are laws and conservations and ways you can figure things out. But this distinction, in some ways, ends up being one just of convenience. It's like, I can talk about forces. I can, in fact, talk about what the resultant force characteristic is with respect to, based upon its energy. And in fact, you can do a mathematical analysis that shows that whether you characterize something with respect to forces or you characterize it with respect to energies, you'll get the same math out of it. But I would submit that the pictures of the world are very different. And I think I'm on good ground here. And I think most physicists and probably most philosophers of science would agree, though I haven't done like the scholarship on it, is that any more energy is the way in which we parse out the world in terms of a scientific method. Force ends up being a way of talking about certain things at a higher level, but it's more heuristic. The way in which the world is interacting, the way in which we balance it out has to do with energies and conservation of energy. So the force piece is a heuristic. That universe of energies being balanced back and forth has to do with what their intrinsic properties are.
Yeah, that's a good segue into chapter 5, because he's going to argue now. Of course, he's been on about the laws of nature from the beginning of the book through the whole book. But now we're going to get a detailed account of how essentialism, and in particular, this idea of the essential and often dispositional nature of things, can actually help us explain the laws of nature in ways that the Humean account and related accounts cannot. And that involves explaining hierarchies in the laws of nature in terms of hierarchies of natural kinds. It involves explaining what he calls the necessity problem, which we'll get into, the idealization problem, and then what he calls the ontological problem, and then the hierarchy problem he calls the structural problem. He starts out chapter 5 paving the way for our understanding of the structural problem by talking about hierarchies of natural kinds, whether they're objects or substances or events/processes. Or finally, facts about the intrinsic nature of things, which is to say their dispositional or structural properties. So for instance, we're very used to this hierarchy talk because we're used to modern science reducing things to parts, right? What I often call mereology on the show. To cut things up into pieces, that's already to establish a hierarchy between the macro level and the micro level. So for instance, with chemical substances, molecules are at one level of the hierarchy, atoms are at another, and then you can look at processes involving molecules related to underlying processes involving atoms or subatomic particles and so on.
On page 89, he kind of talks a little bit about necessity, just to give a picture of what he means by that. He says, it's also widely and although not universally accepted that the laws of nature are in some sense necessary. That is, it is not just an accident that things obey these laws, but there is in some sense in which they must do so. Further on, in philosophers' jargon, they must support counterfactual conditionals.
Do we want to say anything about these hierarchies before we move on to necessity? I think you're right, Chris, that necessity ought to be our focus. I don't want us to get bogged down in hierarchy stuff, but there are some interesting observations.
Well, you already covered that, there's objects or substances, natural kinds as objects and substances, natural kinds as events or processes.
An important point about hierarchies for Ellis is that there's an epistemic structure with respect to hierarchical facts, or it's important to him. Namely, because remember that he's proposing essentialism as explanatorily superior to this other metaphysics that has dumb substance with laws imposed upon it. And so in the back of his mind, which we'll get to the end of the book, is how do I explain very complex and simultaneously apparently random events at the macro level if what I'm claiming is everything is essential and in a sense ultimately determined. So he wants to be able to say that we can take a scientific investigative approach to sort of bore through levels of complexity to get down to simpler and simpler entities and simpler essential properties. And then we can explain the more complex properties and activities and dispositions on the basis of these simpler ones. Because he needs that kind of knowledge structure, if you will, in order to be able to build a case for essentialism as an explanatory construct that's superior. So I think that's why he brings it up and he shows us a few examples, but we don't spend a lot of time. It also parallels in some sense the way, at least taxonomically, some of the sciences categorize their knowledge structures. They are hierarchical. Kingdom, phylum, class, order, family, genus, species.
But you're also pointing, Seth, to a problem that Ellis at some level needs to confront, and I don't know that he does it exactly in this book, is in pushing hard on the essentialism and like the characteristic of facts. He says on 84, the natural properties of things are natural kinds of facts about them, but not any old facts. They are natural kinds of facts about the intrinsic natures of things. And he goes on to give an example of mass. He's going to have to be able to talk about the way in which the kinds of certainty that you have, epistemic certainty that you have at the chemical level, blurs out as you go higher in hierarchy. I think he wants to say ultimately that even in cases where it doesn't apply, where I'm talking about entities that are not natural kinds, characterizing the world in terms of entities that have dispositions is the right way to be thinking about the world, even if it's only analogical at a higher level. I think he's going to make that claim. And we still need to be able to be conscious of the distinction between when I'm talking about natural kind entities that have dispositions versus entities in a higher level hierarchy that things fuzz out in a way. So even in the case of things that might be socially constructed, we ought to be thinking about them as entities that have dispositions, right? I think he will go that far. I think he wants to say this metaphysics about the world isn't just for thinking about science or thinking about small things. It is better to think about the world overall in this way.
The strongest claim he makes is that somehow natural kinds are a constraint on the way that we talk about things like social construction, that's as strong as he wants to get. But yeah, no doubt you're right.
But importantly, that's part of the way he's going to get out of the determinism versus... He basically wants to say that whole discussion, determinism versus free will, is a red herring, because as soon as you start talking about dispositions, you remove this problem. But he's going to have to be able to have an account for, again, how things get fuzzier, epistemologically fuzzier, as we go higher in hierarchies.
Mm-hmm.
I think part of the argument is that, hey, look, there's these hierarchies in natural kinds, and they kind of line up with these different hierarchies in the laws of nature. So, for instance, there's more global laws like conservation of energy, and then more specific statistical laws of interaction involving energy transmission or particle interaction, and you can line that up with dispositional properties of natural kinds. So that's one part of the argument. But I think, Chris, you were getting us into the necessity problem, and I think that's really the most interesting part of this, because philosophers typically make this distinction between logical necessity, which can be parsed out in terms of the semantics of quote-unquote possible worlds, which is not to say, except in the case of David Lewis, that these are real worlds out there. When they get desperate, suddenly all the worlds become real and simultaneously existing. But it's really just about what might happen, right? So when we talk about a possible world, it's just a shorthand for talking about possibility. So there's logical necessity and logical possibility, where necessity means true in all possible worlds, and logic is a good example of what's true in all possible worlds. But I think traditionally, at least according to Ellis, philosophers have not thought about natural necessity in the same way. It's often called nomological necessity, but the idea is that in a different possible world, the laws of nature might be different, even if the things in the world were entirely the same. So we just make up a new script. We make up a new set of rules. We still have electrons. We still have all the other stuff that we have in this world, but we conceive of it as having different laws of nature. And that's something that Ellis is going to argue against. He's going to say, actually, I want this very, very strong version of natural necessity in which if something is a law of nature in this world, it's a law of nature in all worlds. Pretty controversial idea that he's going to argue for.
I'll read a little bit more from page 90 to paint the picture some. He says, although it is widely accepted that the laws of nature must have a kind of necessity, there's no such agreement about the nature of this necessity, other than that of its capacity to support counterfactual or hypothetical reasoning. So the laws of nature have to be discovered empirically, so it's initially implausible to suppose they're analytic or logically necessary, like you were saying. But it's commonly supposed, therefore, the laws of nature are necessary in some weaker sense of necessity. But he wants to give it the stronger sense, it's metaphysically necessary. So as we talked about earlier with something like H2O, that it's all possible water is H2O, not just all water in our world.
Yeah, he doesn't really get into the details until page 97.
And the key part there is that the entities lower on the hierarchy have powers. And then you might have other kinds of powers at the higher level, like the way in which two groups of H2O atoms interact with one another. You may be able to perfectly accurately describe the essential properties of a water molecule such that the way in which water behaves at a certain temperature is a direct consequence. So those laws for that are a direct consequence. But say, for instance, the reason why a H2O molecule is the way it is has to do with the atoms that make up that H2O molecule. And you would go back to saying that the electron as an entity has certain characteristics, its spin, its mass, its charge. Charge in particular is characterized by an electric field, a disposition to behave in certain ways around other things that admit of electromagnetic forces. So the law of interaction between two electrically charged objects is not something that's true about the world independent of those objects. It's true about those objects, and therefore you see it in the world.
This throws me back in some sense when he gets into the talk about chemistry in particular to the pre-Socratic atomists. In a sense, it's like, it's all about the basic thing and the way in which it's combined with other basic things, right? So it's like, if the world was made up of like squares, circles, and triangles, and when a triangle sits on top of a square, it has a certain set of characteristics and when the square's on top of the triangle, there's an easy transition to thinking about what are the essential properties of a thing. As Dylan just said, if you're already talking about what's essential and what's dispositional, you've kind of bought into the construct. And the fact that we can do that so easily, that it's quite natural to slide into that conversation, is another prima facie proof point for this particular theory.
Yes, you can ask a question like physicists have since probably the beginning of trying to understand electricity, magnetism, even gravity, right? Is you end up with this 1 over r squared law, right? That the intensity of the attraction goes as 1 over the square of the distance between the two objects. That's true in gravity. That's true in electricity and magnetism. There was a question like, well, why that? Couldn't it have been 1 over r cubed? Couldn't it have been 1 over r to the 2.675? What is it about that? And you can play out the consequences about the fact that, well, the world would not look the way it does without that being true. And I think that's along the lines of what Ellis is talking about, is as well, the one world that we have has entities in it whose characteristics are observable and objective. And those are the things that are to be discovered about it. Those aren't arbitrary. Those are independent of us, and they're to be discovered. And those are facts about the world.
I want to harp a little bit more on what the necessity problem is exactly. What makes that a problem? We understand logical necessity, I think, right? If certain premises are true, we're forced to a certain conclusion by the rules of logic. And intuitively, we think of force in a similar way, right? There are certain laws of nature, and things necessarily behave in a certain way. But according to Ellis, since Hume, there's something in philosophy of science which tends to treat these necessities as just accidental regularities, or at least this is the Humean position. Things are loose and disconnected. They're accidental regularities, and we supply the tie, right? We can't observe a causal tie. A cause is not an observable entity. And we supply it by habit from our own minds. And if that's true, then the question, well, how do you distinguish that from accidental regularities? Like, hey, there's all the coins in my pockets are dimes. Yep, that's a regularity. That's a generalization. But there's nothing necessary about that. It's contingent. It's accidental. It's not actually a law of nature. So you can't just look at every generalized thing and say, oh, that must reflect a law. And so then the question becomes, how do you distinguish one from the other? And that becomes a problem of inference. His response to that is that if you think of things as having these intrinsic causal powers right there down deep into things, as opposed to the Humean suspicion of those as being occult or something like that, then you can explain this strong sense of natural necessitation, which doesn't have the same mysteriousness that it does for other philosophers, right? So I'm looking at pages 97 and 98 here on natural necessitation theories.
Yeah, I was going to say, there is the Humean picture that you're talking about where he's going to say there is no necessary connections between events. And it's the reason we think it's sort of a psychological attitude that Hume has towards why we generalize and then end up making these sort of like causal inferences, that it's not, we don't take it in the senses and everything like that. That's Hume's point. But yeah, obviously there's people who can think that the laws of nature have a weak kind of necessity that are specific to our world, but don't buy into the idea that there's a stronger sense of necessity, a metaphysical one, where in all possible worlds, this would be necessarily true. It's like different than Hume's point, like it's a little further down, where you can think that there is necessity, which I think the natural necessitation section does get into that a little bit.
Yeah, he thinks there's something mysterious about this, what's called nomological necessity, this kind of in-between hedging of bets between contingency and logical necessity.
The idea that the laws are necessary in the strong sense, but just only in our universe. And so they still are contingent. You could say that the law of gravitation is necessary in our world, but it could have been different given some other world and some other constitution.
So they're contingent between worlds, but necessary in this world. He associates that with Dretsky and some other philosophers.
Just for the record, I've always thought that modal semantics were just a giant smokescreen. And I'm very sympathetic to what Ellis is saying here, but somebody would have to explain to me how that's any different. So you just said that it was nuanced compared to the Humean position. And I'm not seeing any difference between that and the Humean position. The Humean position is there's a regularity. It appears to be necessary in our world. So you're saying what Hume is saying is, but we could wake up tomorrow and the sun might not rise. It just happens to have done it every day for as long as we've been alive. And then we have this other completely say, oh, well, no, the sun has to rise in this world. But remember, it's a possible world. You can think of it psychologically or ontologically. I can conceive of a world where it's not necessary that the sun rises versus there is a world where the sun doesn't rise. And so that particular law of nature is not necessary in that world. I guess maybe I'm not contrasting this to the Humean position, but really, in what sense is your modality working? Is it Armstrongian or Dretskian? Like that kind of, maybe that's the right way to put it. And I just name dropped it. I'm sorry for that. So do you believe it's a real world where this is happening, or are you just talking about counterfactual, like you can conceive? And then I would say, no. Can you actually conceive of a world where such and such a law doesn't hold? I would challenge people on that one.
Yeah, this comes up in chapter 6, and we should jump to this. Unfortunately, the way this book is structured, to follow this whole thread, we have to jump around a bit. But this question of what's possible and the way we think about what's possible, he's going to object to this idea that I can think of logical possibility as just in terms of, hey, what can I imagine at the macroscopic level? If I can imagine a bronze statue dissolving into dust, or if I can imagine it suddenly animating and walking away or sprouting wings and flying away, then that's logically possible because there's nothing contradictory about imagining that. And Ellis's point is that, well, yeah, but we're limited in what we see. We don't see all the way down to the micro level. And it's a poor way to think about possibility because it's just a matter of accident how much we see. If we saw all the way down to the micro level, if we saw the intrinsic nature of things, we would say, no, actually, that's not possible for it to just sprout wings. And so he wants to say that, in fact, we have to take into account the natures of things when we talk about possibility. And the same thing will apply to necessity.
Yeah, I thought about the philosophical zombies argument, which is just often thought of as logically. It's one of those classic cases of people saying, well, it's logically possible we can imagine a human with the same setup as us, except they don't have this one feature, even if it's not physically possible. And he would just reject that.
So they have the same brains, the same brain activity, but because the laws of nature are different, there's no consciousness. That's the zombie argument, and it's supposed to illustrate the hard problem of consciousness. We talked about this on one of our Chalmers episodes.
Can we just back up for just 1 minute? Because I think that setting what we're talking about now into the way in which he characterizes the desiderata for the theory of laws, we're talking about one piece, which is necessity. But he has really 4 pieces, 3 major problems for any law of nature, any account of laws of nature. One's solving the problem of necessity, one's solving a problem of idealization, and one's solving an ontological problem. And the necessity problem is just that we want any account of laws of nature that to give an adequate account of the peculiar necessity that's associated with a law. This is where, on page 90, this is the quote that Chris had. Natural necessity is not like greatness. Laws of nature do not achieve necessity or have necessity thrust upon them. And then there is that they should have objectivity, that they should be discoverable. That is one way of characterizing the idea that it's true not because we're thinking about it. It's true outside of ourselves, right? It stands independent.
So that's the ontological problem. Then there's the idealization problem.
The idealization problem, it has to not just predict what's going to happen, it has to inform our understanding.
Well, it has to explain why things don't behave that way in real life. So laws of nature have an abstract, idealized nature, right? How would something behave in a vacuum, so to speak, speaking metaphorically? How would things behave if there weren't all these other things interfering, all these other causal processes interfering with what we see? So we imagine an idealized system, and it's often not what we see in the real world. So we're not just observing these regularities and saying, oh, here's a law. When we describe a law, we're describing something we haven't actually ever seen because there's too much interference from other stuff.
Yeah. The perfect example is you have projectile motion. You throw a ball through the air. This is Galileo. And he figures out that the way in which projectiles run goes in a particular way. But the fact is that even then, you had the discussion, well, if the wind's blowing, I'm assuming that no other force is acting on the object, right? It's going to follow this parabola. But if the wind's blowing, if there's a lot of air friction, the size of the ball, stuff like that, all of that's going to perturb it. But it's idealized trajectory, this parabola. So why is it that works, even though you have all these other things going on?
And why is it preferred? Yeah.
That's what goes to understanding, right? That ends up being the anchor of our understanding. Its fundamental essence of its behavior is to go in the path of a parabola. This is a way of characterizing Newton's first law, inertia. It's moving and it won't change the way it's moving. It won't change its behavior unless something acts on it to change its behavior. That's a causal claim, right? Something's going to keep doing what it's doing until something acts on it to change that.
So he sets up these 4 desiderata, 3 to 4, the necessity problem, idealization problem, ontological problem. What is it about the world that accounts for the laws? And then the structural problem, which we talked about with the hierarchies. So I had us on the track of just following those threads one at a time. We already talked about the structural part. I think we should finish up our talk about necessity, which spans necessity and possibility, which spans several chapters. And I think where we left off was with the role of what is imaginable in defining possibility and his objection to that. Is there anything more to say about that? So in other words, we can't just say, hey, here's this clean-cut distinction between logical necessity and physical or nomological necessity. I know that it's physically impossible, given our laws of nature, for the statue to walk away. But isn't it logically possible? Because I can, in this cartoonish way, imagine it happening. And I think this is a very powerful part of the book to say, well, no, just because we're thinking about what we can see on what's imaginable on the macro level, that's not actually a good test of possibility, because if we could see everything, if we could look at it at the perspective of the micro level, then we couldn't imagine the same thing as happening in the same way. I don't know the literature on this, if there's a big debate in philosophy about this, but this seems to me a pretty slam dunk argument.
Isn't he saying that the ontological status is the key piece of the necessity status? That's the reason why you have to be careful about the way in which you're using imagination. Using your imagination doesn't mean there are no constraints to right thinking about how the world is. That's only constrained by logical necessity. You need to include ontological necessity in there in order to be thinking about the world correctly.
The way he puts it, and this is on page 113, so there are constraints to our imagination. We can't imagine the bronze statue being read and not read in the same way at the same time, blah, blah, blah.
Yeah, but that's a logical one, right? The law of non-contradiction, that's a logical constraint.
Right, but what's a good example of something that's hard to imagine at the macro level? I can't come up with a good example. But the constraints change depending on whether I'm thinking about macro level objects or objects at the micro level. So in 113, he says, the imaginability tests on manipulating this manifest image at the phenomenological level. But what things are is different from what they look like at the phenomenological level. And so why not subject the imaginability test to the constraints of what things are at the micro level, not just what they are at the phenomenal level. So H2O is water. Water can't just turn into wine because I can imagine that at this cartoon manifest level happening. I have to think about it all the way down to the deep structure of reality and be able to come up with an account of how water would change into wine that way. Otherwise, it's not possible, even logically possible.
To me, the way to think about this is where the hierarchical piece ties in, and the whole epistemic structure is that you would have to say, okay, for water to turn into wine, then, and you'd get down to the point where you'd say, can I imagine that H2O has a different chemical structure, or that H has a different atomic mass, or whatever would be necessary for it to spontaneously, and then you get to the point where you're like, no, I can't even imagine that. So he's basically cautioning us, just because we have imaginations, not to, again, reify our ability to imagine things and put ontological import on them. Because in reality, it's not possible to conceive of water as having a different kind of chemical structure than it does and have it behave in the same way, or vice versa, to have it have the same structure and behave in a different way than it actually does.
And the way you're explaining the thinking process there, Seth, is the way Ellis would, is that when I say, I can't imagine the following, it's there you're limiting your imagination by the ways in which the entities actually behave. This distinction and observing phenomena that break your assumptions is actually where things get discovered, right? If matter acts this way, I can't imagine that the following thing that I'm seeing happening is actually happening. Those are the most exciting times in scientists' lives, right? Is where you end up observing something that is at odds with your actual imagination about the way in which the world ought to work. And in the best of all possible situations, that ends up you having to reimagine what things are in the world.
So the lesson is stop using your imagination.
That's exactly what the lesson is. Exactly.
I just don't treat it as the criterion for possibility. So we will get more into that in the second part, and we will also get into the implications of essentialism for science, for philosophy, for the social sciences. The last two chapters of this book, 7 and 8, are on philosophical implications and wider implications. And so that'll be the bulk of our time in part 2. You can listen to that right now by becoming a subscriber. If not, you can wait a week for the possible world in which the episode comes out. Although, from my point of view, necessarily it will come out. All right. Next time. Thank you.